So a team of scientists was studying the population of salmon in a contaminated lake. They initially put 2 salmon in the lake, and every year the population of salmon tripled. Create an equation to represent the population of salmon, P, after X years. So the first thing we need to determine is this growth or is this decay? So I need to read my problem to see what it actually tells me is happening. So this time it uses the word tripled, and tripled means it grows. So this is growth. Now the A is always what we start with. So when we started this problem, we had 2 salmon in the lake. So 2. And then our rate, okay, our rate of growth this time is tripled, which means times 3. So always we go back to our original equation, which is f of t is equal to a times 1 plus r to the power of the time. Okay, and this time they tell us to use x years. So instead of using t, I'm using x years. And it tells me I need to represent the population of salmon with P. So this is going to be P this time, which means population. And then there's one other really important thing here. The 1 plus R is when R is a percent. But here we don't have a percent. Triple is not a percent. So we are not going to add 1. Okay, so we are not going to add 1. So when we're writing this equation, we start with our P. So P equals our A, which we said was 2. And then instead of doing 1 plus the rate, we're just going to put the rate there because it's not a percent. So it's to the times 3 because it's tripled. And then instead of t, it tells me to use x. So my equation is p equals 2, parentheses 3 to the power of x. Now, when I need to find out, it says what was the population of salmon after 12 years? So 12 years is what I'm looking at now. So that is an x. So x equals 12. So I always start by typing it in Desmos. So I've typed it in Desmos, and we're going to use our trick. We are going to press this gear right up here, right, and then table, and it'll automatically make a table for us. And we could pop in the number 12 and see how many salmon were there. So our number of salmon is 1.062882 times 10 to the 6th power. Now this number seems kind of confusing because it's in scientific notation. So what that means is I've got to take the 6 and I got to move the decimal point over 6 places to make the number bigger since it's a positive 6. So that means it's 1.062882 and I'm moving it 6 places. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. Now my new decimal point is right here. So my number, that means, is 1062882. And because we're not going to deal with any parts of a salmon, we're just going to leave it like that. So that is 1,062,882 salmon. Sorry, not million salmon. Salmon. The other way you could have done this is you could have typed that back into Desmos and let Desmos do it for you. So if I'm on Desmos, I could type this in 1.062882, and that's at times, so it's times 10 to the 6th power, and it does give me the number right here as well. Okay, try out number 4 on your own.